Hi, welcome to my channel. This is a kind of a reaction to a small post that Robert Martin made on the SQL language. Robert, or Uncle Bob, as some people refer to him, is kind of a well-known author, has a number of books around things in the Agile space as well as the object-oriented space in terms of object-oriented programming and object-oriented design and process as well. And certainly Robert does have the gift of, coming up with rethinking things that make people question the fundamentals, and that's not necessarily a bad thing. Looking at it, of course, fundamentally it's one of those things where, as some of the interesting and compelling as some of the arguments might be there, well, why are we using SQL? Gosh, it's so clunky. There's tons of variance around it. Never quite seems to do the thing around it. There's a couple things here that just basically, that's not going to happen, and it's not going to happen for some very good reasons. Also, I will have to say that this is not the first time this has come up. CJ Date, who is a person that's very well known in the in the relational database community, who's done a lot of work on the relational model and normal forms, wrote a book on this called, I think basically it's databases, types, and the relational model, the third manifesto. I can't remember if that's the exact title. I think that's the case. It may be data types or something like that. But despite, given his name, the third manifesto, shockingly, nothing really came out of this. And he proposed a whole different language called Tutorial D, or just D for short, which would basically fix a lot of SQL's shortcomings. And not only that, but spent a lot of time about how to overcome the problems with nulls. And basically, do nulls introduce a lot of issues in relational databases? Yes, they do. Are these workarounds going to still be happening? Yes. Are there some interesting ideas on how you could do it differently? For sure. But again, all of that kind of came to naught. It didn't really have that much influence on even the newer versions of the SQL dialect itself. And the reason being, obviously, is that it seems like, well, okay, this is just organizational inertia. We can do better. Well, maybe, but not good enough to really cause it to be replaced. And the reason being is that for two reasons. One, SQL is a fairly flexible language. It's easy to have multiple dialects in. And that may seem, oh my God, you're actually making things worse. But what that does is it means that you can actually allow database specific extensions to be added into the language in a way that is fairly smooth, that doesn't feel incredibly clunky. Certainly not clunky enough to throw the whole thing out. One of the things I'll point to, for example, is all the extensions that SQL Server did around for JSON objects, and so on and so forth. So it's really kind of a dialect of languages. But more importantly, this dialect of languages is an abstract, declarative way of saying, this is what I want. When you look at SQL, it's fundamentally important to realize that, yes, you can write incredibly bad queries that don't get you what you want, or that do it in a really, really bad way. But ultimately, a good query is still a statement about what things you want to be put together. And it is up to the relational database system to figure out the best way to do that. And that is a hugely important distinction. If you make a lower level API to that, you're going to have to go into more of the details about how each specific database engine does things. And I'm here to tell you, no database vendor in their right mind would expose that level of control to any programmer, because they want to be able to change that to do optimizations at will, from not even major version to major version, but from minor version to minor version. Two, you're not going to get it any better than the query optimizer and plan generator is going to. And the reason being is that the query optimizer and the plan generator could take advantage of the fact of not of knowing all the things that were happening or true about the database when that query was written, but when it was actually executed. And that's a big difference. Indexes get changed. Schemas get changed somewhat. You add columns or remove columns. You do certain types of things. The database you're targeting with a certain query may be in terms of how it's stored, fundamentally different enough that your query may be running in a completely different way. Worst case scenario, that slows down your performance and you have to really retarget things. But the more common case is that through indexing and careful optimization, that query all of a sudden runs much better. And if you do stuff from the low level types of things where it's like, okay, I want to do, instead of a table scan, I want to look at this index as a lower level API. Well, if that index no longer exists, boom, it's just going to run in an error. And then B, if you did the table scan and someone added an index, you're just never going to get better performance. So it's a higher level abstract thing that can be turned into that set of a query plan. And here's the thing, databases have tools in them that allow them to cache queries. So again, you can always, the first thing to do is that if you have something that's complex SQL and you have the ability to do it, add a stored procedure to the SQL database, call it that way, right? You do not need to have huge amounts of embedded text in your program. You can have scripts that add a bunch of stored procedures. That works great. It's awesome. But even ad hoc queries that get ran that are either generated by, those text templates or by object relational systems, those plans are fundamentally cached and managed by the query manager and the plan optimizer. So the overhead introduced by having to parse out the SQL and turn it into that is minuscule. It's very small. In fact, it's just swallowed up by network latency at this point. Basically, if you look at it, it just will inhale SQL queries, even the most complex ones, and turns them into a plan and get that data out. And the complexity of the SQL in almost every single case is just noise in the overall time it takes to run that transaction. And so you can think of SQL as being just this high-level protocol for interacting with databases. And if you think about it that way, I can't see any API that would really make it so much better that it would be something that we're like, oh, we're going to take all this SQL stuff and kind of put it into the background and have this new way with interacting with things. Not only that, but there's a reason no SQL databases and services have SQL-like syntaxes, because there's an advantage for them also to have a declarative way of saying, this is what I want, and then figuring out actually how to give it to them, versus having to iteratively say, oh, this is what I want you to do to get the results I want to get to. That's the ultimate part that makes a relational database or no SQL database very useful. You are using a higher level declarative abstraction that can be optimized to give you data, and that allows you the flexibility for that data schemas to have some level of evolution without just breaking all your queries. The second thing about this is that it also seems that basically it's one of those things where one would put out, it's like, well, from an ORM standpoint, ORMs are just awful and difficult to deal with, and they could be a lot better done if you were not having to deal with SQL, and if we had this lower level type of stuff, could we make better ORMs? And the thing about this is that my view is a bit biased here, and my bias comes from the fact that I am a C# programmer, have been doing C# in a while, and for me and many other C# programmers, we do not have a problem with object relational mapping. Between Entity Framework Core and Dapper, we are good. They work great, they are very mature, and they provide a lot of wonderful features, and they have just worked. And the reason that they do is because C# added a feature in that allows us to express in that declarative query type of stuff in a more object-oriented way, but that can still be translated in SQL or those other database sources. We have LINQ, basically, is what I'm coming down to. And LINQ is that fundamental feature that makes object relational mapping so much better to manage and deal with. And the reason being is that once you understand how queries work in C#, it's very easy to just do the common types of things and have it work very well. Writing a simple LINQ statement, either using the kind of the API version, or basically the small domain specific language, the for where statements that you can do in a C#. It is an excellent way of expressing, again, that declarative thing on the object side, making it very easy to translate over to SQL. Not only that, but of course, that link statement can also just take an in-memory set of objects and do the same type of thing. So once you have link, you have entity framework, and then you have something like Dapper where you need to do what people will call the micro ORM things, which is like, I just want to call a stored procedure or make a simple, text, a parameterized query and send it off and just give me back the thing as a set of objects. C# makes that, that super dead easy. Dapper makes that really, really simple. So for me, one of the things about that is looking about this, there's this crisis in ORMs with stuff like that. Not in my world. And the thing about that is that when you look at it, there probably are good ways of doing this stuff, but it's one of those things where ultimately what you would need, and where the problem is not on, we need lower level stuff for accessing the database. What is missing in those higher level languages is a notion of declaratively saying, this is what a query looks like in terms of how the objects I want to get back look like, right? And then translating that into a database. If you don't have that first part of, here's how I declaratively want to set up a query, right? Then the second part, a lower level API or a different API to the database, is going to make no difference in the world because you don't fundamentally have that first part right. And that's what the people that get really complain about SQL and all this other types of stuff fundamentally miss is that what's missing is not the database part. It's the language part. And then the thing about it is that it would be difficult to replicate. And so that's the fundamental hard part about this is that link is not just, it's a nice library. What makes this very difficult is that when C# 4 came around and they decided to add link into doing this, they had to have add some fundamental new things to the language and the runtime to do this. And fundamentally what this is that they had to have the notion of expressions and expression trees. And they had to have a whole set of type hierarchies around expressions and expression trees that they had to add. It's very complicated. They had to add in extension methods. It snowballed into a ton of language features. And what it ultimately came down to is that in C#, I can say, hey, if I have this query statement, or I have this lambda, or I have this block here, or this set of things, right? When you do this and compile it, do not compile it as a set of function calls and stuff like that into ultimately the IL. I want you to capture it as an expression tree. And as an expression tree, it means something I can walk through, and then I can optimize, and then I can run stuff on. And so that's ultimately how Link can do all of its magic. And that's not perfect by any stretch of the imagination. One of the things that makes it very difficult that it still has an issue about is that it can't say without, basically, it has to look and do certain things at runtime and look and say, I can't turn this statement you have into a database statement. The reason being is that it can't enforce that certain arbitrary function calls aren't made. And so as much as we try to do this, it just can't do that kind of stuff. So you as a developer have to kind of know what functions you can and can't call in a link statement versus a general C# statement. And so there are some very knowledge-specific things like that. But compared to what Hibernate and either other newer versions of Java-based ORMs or JavaScript or TypeScript ORMs and stuff like that, it's miles ahead of what anybody's doing. So if there's any innovation to be had, it's on the language side. And that's where I think Bob and the other people that are commenting onto this really missed it, is that no, it's not this underlying low-level API or a different API we need in databases. You need a whole set of language features so that you could fundamentally understand this notion of how to declare something in terms of these are the objects I want to get based on this object schema that you can then translate to an object store, a set of inline objects, or a relational database, so on and so forth. And that's really where the solution should be. And yes, that means you should look to C#, which I think does a spectacularly good job of it. And it's one of the reasons where I think that is C# secret weapon in the enterprise. that now, especially that they are a class platform, is going to work out much, much better for them. Anyway, thanks for watching, and I'll see you in the next video.